Okay, we have VDM syntax and also semantic. VDM syntax and also semantic. This one is very important because in the VDM, Vienna development method is the environment for modeling and development of the sequential software. Okay, and then we also discuss about the language that has evolved from the metaphor, the language that has been used by IBM. Okay, IBM, and then used in the IBM Vienna Development Laboratory for specifying and semantic of the uh, PLI programming language in early 70s. Okay. Okay, for this one, okay, for syntax and semantic, syntax and semantic, the VDM-SL and VDM++ syntax and semantic are described at the length of VDM2 languages in the manuals. They have a manual and also available in text. Uh, This one include the basic type, include the boolean numbers. Okay, numbers. Normally we have natural numbers. We have the integer. We have the rational and real, and also we have characters. Characters. Okay. VDM. Okay. Okay. We have a basic type. Basic type. Okay. Basic type. Normally we have boolean. Include the boolean. Okay, boolean, and then we also have the numbers. Numbers here, including the natural number. We have the integer, and then we also have the rational and real. Sekejap, sekejap saya ni. Saya share screen. Tak nampak eh? Kamu tengok balik dekat screen kamu tu. Biasanya when Google Meet. Okay, resume. Okay, sorry. Resume presentation. Nampak dah? Is it okay now? Sorry, because last time I'm sharing another content. Okay, uh, numbers we have a natural, integer, rational, or real numbers. This one is the basically is the type. Okay, and then also be remember that in the accordance of VDM abstraction principle, this correspond mathematical notation of numbers are not bounded by the constraint due to the presentation in computing hardware. Okay, if the user wishes to specifying the limit, they can because the number itself are relevant to the problem that being modeled. It also possible to do so explicitly by means of the invariant. Okay, this one for the range. This one range for the range is unlimited lah. Unlimited. Why? Because it is specified by the invariant. Okay, specified by the invariant. Okay, what is invariant? Invariant are logical expression that you have learned in the discrete structure. It's basically from the predicate. Okay, basically from the predicate, and then uh, representation condition to be respected by all elements that being attached. Being attached. Okay. Why it is unlimited? Because it defined by the uh, problem. Problem defined by the problems that be model and then explicitly defined by the invariant. Invariant. Okay, this one is the basic type of the VDM. Okay, and then we have VDM. We have several syntax, or we can call it as a semantic. Okay, and then we have the ISO standard. ISO standard contain a formal definition of languages semantic. In the reminder of this presentation, the ISO defined interchange by the ASCII syntax is being used. Some of the texts prefer a more concise mathematical syntax. Later, this one we discuss mathematical syntax. We have discussed mathematical by the numbers, Boolean numbers, natural, integer, rational, and real. Okay, and then VDM-SL model is a system description given in the terms of the functionality. It's more on the functionality that perform on the data. It consists of several definitions, a series of definitions of data type and function or operation performed upon them. Okay, this one also based on the model. Model. Okay, model that defined by the invariant or predicates. Okay. Okay, so far, do you have any question? Okay, ke? Zaim, okay ke? Is that okay? Syawal, boleh ikut ke? Okay, this one is a modeling for VDM-SL. Is a system description given by in the term of the functionality. VDM-SL is given by the functionality that perform on the data, and the data is performed by its functionality. Okay, and then it consists a series of definition of data types and also function operation performed upon them. This one is based on the model modeling domain. Domain. Okay, in here, as you can see, we have several basic type. Basic type that you also found in the programming languages such as Java and also C++, that you have learned before in databases and several subjects. Okay, first we have a Boolean data type. Basically, we have true and false. Okay, and then we have natural numbers. Natural numbers, we have two here. Natural numbers including zero and excluding zero. Okay, and then we have integers. We have rational numbers, real numbers, character, token, and code. Code. Code here is a syntax. Syntax and data type that characterize the VDM-SL. Okay, a simple definition to representing VDM-SL is we have the simple data type definition representing the latitude of the aircraft. Aircraft. Okay, for example, Okay, I give you example. Okay, for the VDM-SL. Nanti kamu nak tak nota-nota saya ni? Nota yang saya contoh-contoh ni kamu nak? Nak Nak Tak cantik pun. Okay, example dia, we have simple data type lah. Simple data type. Okay, simple data type representing the latitude. Latitude ni apa dia? Latitude. Okay, latitude basically latitude of aircraft lah. Aircraft. Aircraft. Okay. How to define? Okay. We define like this, latitude. Okay. Latitude equivalent to real numbers. Okay, if it is designed to restrict the latitude to the range of number from -90 to 90, inclusive, additional condition is added to the data type in the form of invariant. Okay, because I have explained to you what is invariant. Invariant is based on the predicate. Predicate that limit up the domain. Limit up the domain. Okay, for example, here we have a latitude equivalent to real, and then we have invariant, INV. Put like that, invariant latitude. Okay, latitude equivalent to -90 until it's less than or equal to latitude. Okay, and okay, this one, because this one is the predicate, latitude. Okay, is less than or equal to 90 lah. Okay, simple Okay, we have a latitude, and then how you want to define the range. Again, if you want to define the range or limit, you need to have the invariant. Invariant. Yang ni saya dah terangkan tadi. I have explained before. Okay. If you have the limitation of your problem, you need to have the invariant based on the predicate. This one. Okay, Sazwan boleh ke? Yang Bin, are you okay? Yang Bin, Azim okay ke Azim? Patty, Patty are you okay? Semua ni ganggu masa tidur Okay, the invariant is an integral part of the data type. Again, invariant is integral part of data type. Thus, it is not possible to create a value of a type of latitude that do not respect the invariant. The modeler must ensure that all the function and operation to create such element respected to the invariant, because invariant is the integral part of data type. Okay, invariant is a integral part. Integral part. Okay, invariant. Nota sini. Invariant is a integral part of data type. Okay. Invariant is integral part of data type that create create a value to the latitude. Okay, it create a value to the latitude, the range of the latitude. For example, if you define the latitude into the real, okay, and then the latitude is from the negative 90 until 90 degree. Okay, this one is how you want to define. Okay, VDM-SL also contain type constructor for building uh, union. And then a model are typically built around the structure collection of the value. So VDM-SL provide a type constructor that supports several collection type, such as set, such as sequences, such as finite function, and so on. This one is for VDM-SL. Okay, this one is another example for data type. Okay, and this one I have explained that represent the main data for the model system, and each data type introduce a new type name and give a representation. In terms of basic type, in terms of type are already introduced. This one is the to modeling the user identifier based on invariant. Okay, and then we have type here. We have user ID is equal to natural number NAT. Okay, how you want to specify the limit? Okay, you specify by using the invariant, because invariant is integral part of data type. Okay. Okay, and then you have a basic type, numeric, we have character, token, and code type. Code type like this. Okay, this one I have explained. Okay, we have a Boolean operators such as equality and inequality. Okay, and then the language does not fix maximum or minimum representable or precision for real numbers. Such constraints are defined where are required to each model by means of data type invariant. Okay, this one I have explained what is invariant. Okay, you must use invariant because of the predicate, based on the predicate. Okay, okay, and then denoting the condition that must be respected by all elements of the defined type. Okay, this one is very simple. I have explained this one basic type. Okay, this one I explained. Okay, and then continue. If you want to have some limit of your data type, okay, you must use the uh, integral modeling. For example, here you have invariant UID. This one also use the invariant INV UID equal to is same by UID is a limit by 9,999 lah. Okay, you must use the natural numbers lah. Okay, okay, how you want to define the invariant? Invariant is based on the predicate. Okay, and then continue. Invariant can be arbitrarily complex logical expressions. Okay, and membership of defined type is limited. Okay, the other basic type include the character for the characters. Okay, we have some characters uh, for adding some the complexity, complexity, because in predicate you can have a compound statement. Compound statement. You can joining the statement. In such cases, the member of the type may be represented by the structural token. Structural token means that there is no integral part. Okay, there is no integral part of model. This one is important. And then the values of the token type can only be compared for equality. No other operators are defined on them because they have a structureless token. Okay, and then okay, this one is a basic type. We can have, for example, we have the modeling traffic signal controller. Controller, we have red, amber, flashing amber, and green. Amber ni color apa? What is the color of the amber? Color apa ni amber? Joshua, what is amber ni color apa? It is not yellow. What is amber? Nurul Atira, amber tu apa dia? Color apa? Nurul Atira ada. Amber tu color apa? Yalah, RGB color. Dia color between yellow and orange. It is not yellow, it is not orange. It is in between. Bukan orange, dia in between. In between yellow, lebih kurang lah. Dia amber is apa macam mana nak cakap it between yellow and orange. It is not yellow, it is not orange. We call it as uh, uh, yellow, brown red colours lah. Dia lebih kurang red sikit. Apa yellow, vivid yellow. Okay, it is a vivid yellow lah. In between yellow and orange, it is a vivid. Okay, this one is color of traffic light. Traffic light signal. Okay, and then we have amber, we have flashing amber and green. Okay, this one you specified the using code because the values of code known as code literal. Literal may only be compared for equality. Okay, we have colors. We compare the colors. Okay, and then for the structuring VDM-SL, we also have the naming convention. Is followed by name of the module of naming. And then in structuring VDM-SL, we need to import some of the definition, some of definition that can be imported. Okay, later I give you the PDF that explaining all the model structure, data, functionality, state, and operation. Okay, this one is the how you want to model the VDM and VDM plus plus. Okay, structuring in the VDM. Okay, basically for the structure and also for the entities. Okay, giving the entity use in a semantic description, we need to import some of signatures or some of the uh, pattern that use specific type, values, and also functions. Basically, when you want to import signature, you use the import keyword. Import keyword. Okay, and then also when you want to export, okay, using the signature can either be simply consist the keyword all of the sequences of export a signature. Okay, and then more exotic features in earlier VDM-SL tools. There was also many modules and instantiations of the module because of the uh, VDM plus plus. Okay, and then there are also substantial number of tools that can challenge us with these features. And then after that, VDM-SL continue to have the VDM plus plus. Okay, this one is VDM plus plus class structure. Basically, this one is based on the object oriented, object oriented OO. Okay, when you talk about object oriented, you can have the characteristic of object oriented such as inherited, and then you can have also the access modifier to access the hiding informations that are hidden between the modifier, such as we have the private, public, and protected. This one. Okay. Okay, this one is the for the VDM structure. It is different from the VDM-SL because for the VDM-SL is more on the semantic that has a lot of problems lah. Problems due to the with uh, due to the industrial application and a substantial number of tools. Okay, this one is the big problem for the VDM-SL. Okay, and then VDM++ takes a rather pragmatic line. Okay, this one is to use the permission of predicate that describe the condition under the operation for the VDM++. Is more on the object oriented, and then representing the number of each time operation in object has been requested, activated, or completed. Okay, this one for the VDM++. We want to model the functions. Okay, for example, we have a function square root. Square root for calculating the square root for natural numbers. Okay, and then square root, we define x as a natural number, r for real, and then we are required to have the pre and post condition, and then for the post condition, r multiplied by r equivalent to x. Okay, and then the different thing between VDM++ and VDM-SL, VDM-SL are required to be deterministic by the invariant. Okay, but for the VDM++ is more on the pre and post condition, based on pre and post condition that satisfy the operation of the object. Either the object requested, activated, or completed. Okay, VDM plus plus is based on object lah. The main structure is the object. This one you need to know about how uh, object requested. Okay, they have several activity here: requested, activated, or completed. Okay, okay because of that, for VDM-SL, function do not have a side effect. For example, in VDM classes, we have some of the uh, state modeling. This one based on the state modeling. For the VDM++, we have the functional modeling based on object oriented. For the state-based modeling, you need to have the single variable. Okay, and then you need to understand what is the change state variable. This one is you known as a global variable. Okay, this one is VDM++. Okay, you need instead define as instant variable. Okay, okay, in VDM++, this would be instead of defined as this one. Okay, for the VDM-SL, Okay, this one is VDM-SL. This one is VDM++. Okay, VDM++, you need to have the object, status of the object. Okay, status of the object. Okay, some state register equal to natural. Okay, this one state register of for the natural you should n, and for VDM++ no need because you instantiate the object. Okay, you need to instantiate of the object. Okay, class. I think for the summary, VDM is large languages that have many constructs that might appear some sort like exotic compared to general purpose programming languages. Okay, such as Ada and Java. And then we must remember, however, that the intent of the purpose of VDM is not to program, but moreover, it is to model program to have the behavior of the model, and then you want to know what is the state of the program. And then the level of abstraction is very necessarily from the low to the higher because of the general purpose languages. We can also specify the model using a high level construct such as set, map, and implicit function. This one in the VDM plus plus, without having to worry how they will be implemented. Okay, you can see the example is very clear. Okay, for the VDM plus plus, uh, it's not stated n, begin and end, because this one is the for the VDM-SL. Yes, you need to state the program, either the state is ended. Okay, this one is the example. Okay, so far, do you have any question? Is it okay? Is it okay, guys? Okay, if